In this video, you're watching the first lesson in Mix and Flow of Matter. This will be our introduction to the science unit of chemistry. So the focus of this unit will be on, well, matter, how matter can be mixed, and the states of matter, as well as its practical uses. So first off, because this is a chemistry unit, what is chemistry, right? Well, there are three main branches of science, which are physics, biology, and chemistry, and they all break out into different other more specific forms of science. So in chemistry, you can study organic chemistry, in biology, you can study ecology, and in physics, you can study light. So what is chemistry? What makes it different from biology and physics? Well, chemistry is the study of matter. Well, then what's matter? Well, matter is everything that is not energy. Not the best definition, but that is the definition of matter. Anything that is not energy is matter. So matter is everything that is not energy. And we'll go into a little bit more detail as we go along, but this is a really good sort of quick and easy definition of what chemistry is, the study of matter. That's what chemistry is, the study of matter. And matter is everything that is not energy. Physics tends to deal with more the energy side, but chemistry dabbles in that as well. So what is matter made out of? What is matter? Right? Everything that isn't energy. So what's matter made out of? Matter is made out of atoms. So we're breaking this down. We went from what is chemistry, the study of matter. Then we said, what is matter? Matter is everything that is not energy. And now we're saying, well, matter is made out of things called atoms. Now, what is the atom? We're just asking question after question after question, and that's basically how science works, right? We find something, we observe, we give it an explanation, and then we say, well, why does that explanation work? And then why does that explanation work? So this is sort of following down that path of scientific thinking. So what is an atom? The atom is one of the smallest things discovered and makes up everything that isn't energy, right? Because matter is everything that isn't an energy. So matter is everything, atoms make up everything that isn't energy. And so this is a bit of an old model of an atom, but it's the popular image of what an atom is. And there are three important parts of an atom. We have, I'll say red for proton, we got the blue for neutron, and we got the little dudes over here, the E's for electrons. And all atoms are made up of those three parts, or some combination of those three parts, which I think is really interesting because only three things and different combinations of them make over 100 different materials. You add one different proton to gold, you have a different element altogether. So, atoms can combine to make compounds and molecules. So here we have a crude drawing of a sodium atom and a chlorine atom, right? I'm just using circles because, again, I don't want to do this over and over again. So we got sodium and chlorine. Now, sodium is a metal. It's a metal that is highly reactive. And we have chlorine, which is a relatively reactive non-metal. And so when you mix this metal and this non-metal, it's not a metal, together, you make Na, forgive my writing again, Cl. So what is NaCl? Well, it's really just a fancy word for salt. Well, that looks like 5, but that's an S, salt. So you take a metal and you take a gas and you have you have an ion called salt. So sodium plus chlorine makes sodium chloride, also known as salt. So the reason why I find this interesting is because, well, sodium, if you put sodium in water, it explodes. It will react violently and explode, and you can Google this. It is highly reactive. And chlorine, well, chlorine exists as a gas. And chlorine gas is very, very deadly. It was used in World War I. So you take something that is incredibly deadly, you take something that is incredibly explosive, and you have something that you eat every day. And you don't explode, and your lungs don't burn. So combining atoms completely changes their properties and behaviors, which I think is really cool. So now we're going to move on to states of matter. What are the 3 states of matter? There are 3 main states of matter that we'll talk about. Technically, there are 5. Actually, there might be 6, but we're going to focus on 3. So, what are the 3 states of matter? And you should know this. It's very common. One is called solid, the other one's called liquid, and the last one's called gas. You have 3 states of matter: solid, liquid, and gas. And so what do I mean by 3 states? Really, when I say states, I don't mean countries, I mean forms. What are the 3 forms of matter? On Earth, these are the 3 most common forms of matter that exist. Now in space, it's the 4th type, and we'll talk about that later. I won't test you on the 4th type, but no solid, liquid, and gas. If I ask you states of matter, it's dealing with solid, liquid, and gas. So, which of the 3 states has the most energy? Right? Which of the 3 states, solid, liquid, or gas, has the most energy involved? Yes, matter is everything that isn't energy, but matter can have energy. Kind of like saying, I'm not an apple, but I can have an apple. Right? So, energy can exist in matter, and that's how most things move from one state to the other. Right? So, when we look at this picture, we see that we have solid, liquid, and gas. And solid has the lowest energy. It has the lowest amount of energy. Liquid is in the middle, and gas has the most out of the 3. Right? So, solid matter doesn't have a ton of energy. But as you add energy, you move to the next state, liquid. And as you add more energy, you can get gas, which is vapor. So as you move up in terms of energy levels, or as you add energy, you have a different state of matter. And the opposite is true when you start to take away energy. So when you go from vapor or gas, and you start taking away that energy, well, it becomes liquid. And when you start taking away more energy, it goes back to solid. Now this is a really good example, classic example, ice. Right? It's just solid water. The water molecules, the different atoms that make up water, are bonded together in a nice, tight shape. And that shape makes a cube, or any shape that it can fit in, and that's ice. We have ice. Now, what type of energy do we add to ice to melt it? Well, we can add heat. So as you add heat, which is a type of energy, you can melt the ice into liquid. Well, let's say you start adding more heat to the liquid. Well, it starts to boil. Well, what is that called? Boiling. Well, when you boil water, it doesn't just vanish, it evaporates. It evaporates into gas. So as you add more energy, you change the state from solid to liquid and potentially gas. And as you cool gas down, the gas will go back to being a liquid. And then as you cool it down even further, put it in the fridge, you can cool it down to solid. So different amounts of energy determine the state of the matter you're in. So this is a visual of the 3 states of matter. You have solid, and it's backwards from the other one, but it's solid, liquid, and gas. And these little balls here are to represent the atoms and molecules in them. So let's pretend this was water, right? So if we look at our solid, we can take a look at our solid here. You can see that all those green balls are tightly packed together to make a cube. and they're stuck and they're not really moving, they're not bouncing around, right? And that's basically what ice is. They're water molecules sort of sitting still. They are moving, they are, but they're not moving that fast and they're bonding together to hold relatively still. Well, then as you add more energy, to make it liquid, well, the molecules start to bounce around and move around, and that's why liquid doesn't really hold a shape, right? You can't just hold a ball of water, the water will flow away because the molecules and the atoms are moving. Well, you can hold an ice cube because the molecules are holding together, they're holding each other, and they don't have a lot of energy, they're not bouncing around. And as you add even more energy to make it a gas, from liquid to gas, there's even more movement, and the molecules are even further apart. And one thing you may also notice is, look how close all the balls are together in our ice cube, or our visual of ice. All the molecules and atoms are really close together. While when you go to liquid, there's space. There's much more space between the green atoms, or molecules. And as you add more energy, there's even more space between the molecules. And that's what really defines solid, liquid, and gas. The molecules are really close together in solid because they're not moving, and they bond. In a liquid, some of the bonds are still there, but they're moving around. And in gas, well, there's not really any bonds, and the molecules and atoms are moving around very quickly. So, in words, gases have the most energy, and so the molecules move around the most. Liquids are in the middle. The molecules move, but they're not that far apart. And solids have the least amount of energy. The molecules are very close together. And so that's the big differences between the three states of matter. Gases have the most amount of energy, and they move around, and there's tons of space. Liquids, they're in the middle, they move around, but they're not too far away. And solids, they have the least amount of energy. The molecules and atoms are close together, and so they don't really move, and you can hold solids, while liquids and gases you really can't. Fourth state of matter. This is more of an interest point. There is a fourth state of matter, and oddly enough, it is the most common form of matter in space. So this makes up the majority of matter in the universe. Well, besides dark matter, but makes the majority of matter that we know of, and it's not that present unless you count lightning storms. That is, I can click, that is plasma. This video will show you how to make plasma, don't, but it's an interesting experiment to see. So plasma is when you give even more energy to something. So solid, you add more energy, you go liquid. You add more energy, you have gas. But if you add even more energy, the atoms kind of fly apart a little bit, and you kind of have plasma. That's the fourth state of matter. So everything can move from one state to the next, potentially. It's the amount of energy required, right? This is called a physical change. This is called a physical change, and you need to know that, right? It's changing its physical state. Some things just need more energy. Ice is pretty easy, right? Ice, you heat it up to 1, 2, 3 degrees, ice will melt into liquid. You heat up water to 100 degrees, you have gas. Not that hot, to be honest. But if you look at iron, well, iron stays solid for basically a wide range of degrees. But to work iron, to melt it down, and how we use it to make different shapes, you have to heat iron to 1500 degrees. And you get liquid iron, right? And potentially about, I think, 2,800 to about 4,000 degrees, I think, you get gaseous iron. Now, you won't see iron as a gas because it doesn't ever really get hot enough to make iron gas, and there would be no point. We don't have a use for gaseous iron. So Really, it's just these two that we'll see commonly because we manipulate iron to make buildings, to make objects, to make statues, etc. So everything can move from one state to the next. And that is called a physical change. A change from one state, for example, solid to liquid, is a physical change. So this will just be a quick review that you can do as you look at the video. I'm not going to go through it, but this is just something quick you can do on your own to review some of your knowledge. So, the way a substance changes state can be called different things. So I mentioned some of them. Going from solid to liquid, well, that's melting. You're melting ice. Easy. Liquid to solid, well, that's freezing, right? When you freeze water, you're making ice. Liquid to gas, well, that's evaporation, or vaporization if you want to be fancy. But I'll take evaporation as well. Gas to liquid, well, that's condensation. Now, this word might be a little difficult, but if you understand what the word means, I hope it'll be a little bit easier. To condense something is to hold it together. So gas is very spread out. The molecules are very, very spread out. So when you go from gas to liquid, you are condensing it. You are bringing the atoms together. So it's called condensation. Now, let's say we skipped the liquid step altogether. Gas straight to solid. We skip liquid. That can happen. That's called sublimation. Sublimation. And solid to gas is called deposition. Now, I have a small YouTube video here regarding sublimation from gas to solid or solid to gas. Oh, I mixed those up, actually. Yeah, whoops, my bad. My bad. There we go. There we go. That makes much more sense. So, solid to gas is sublimation, while gas to solid is deposition. To deposit, the gas is depositing, while solid to gas is subliming. And an example in the real world would be dry ice. Dry ice is solid or frozen carbon dioxide. And to get carbon dioxide to be solid, you have to reach very cold temperatures. So if you bring carbon dioxide to a room that is a normal temperature, the atoms and the molecules will immediately fly off as gas. And so you just sublimate the solid to gas. If changing states is a physical change, what is a chemical change? Well, a chemical change is not a change in state, but a change in the molecules. So when we looked at physical changes, the iron went from solid iron to liquid iron. It's still iron. There's still iron atoms. It's still only iron atoms, and only iron atoms bonded with each other. There's no new bonds, there's no changes of abilities or changes of properties other than the obvious one of solid to liquid. A chemical change is a bit more complicated. So this is a pictorial example of burning something called a methane. Now methane is a natural gas. It's also a gas you make when you fart. So we have methane. I'm just going to put Me for methane. And you have oxygen. You have oxygen. So I'm going to put O for oxygen. When you combine these two, they usually burn. That's how you create combustion. And you create CO2, as you know, as carbon dioxide, and H2O, which is water. Now, you notice when you do this, when you create this change, you no longer have methane. You no longer have oxygen. Well, you have oxygen atoms, but you don't have oxygen molecules. You don't have these oxygens put together. You have carbon dioxide. So the carbon jumped to the oxygen, and the hydrogen, these white ones, jumped to other oxygens. These are different molecules. These are different things. They're just different. It's not liquid iron and solid iron. It's methane to carbon dioxide and water. So they're different. They're different chemicals. And that's a chemical change. You made or synthesized different chemicals. So how do you know if there's been a chemical change? What are some signs? You mix two things together, you don't know if you created a chemical change. Well, you may see bubbles when you did not add heat, right? Mix vinegar and baking soda together. You'll see bubbles. Well, you didn't heat it up, but it made bubbles. That's a sign a gas was made, a gas that wasn't there before. So that's a chemical change. You created new chemicals into your mixture. Or you didn't create them, but they formed. You may smell something, right? A new molecule came together, and now you have something that creates a smell. You may feel a change in temperature. Back to vinegar and baking soda, if you mix them together and you touch the glass that it was in, it'll feel warm, but you didn't add heat. So something's happening to the molecules and atoms to release heat or take away heat. You may see a change in color, right? Gold has one color, silver has another. So if you start seeing changes in color, that means the molecules and the atoms are reacting and changing to show different chemicals that have different color. These are all signs that a chemical reaction is taking place. So try and know at least these three. There are many more. But these three are pretty good tells. If you smell something, change in temperature, or see a change in color. Now remember, the change in temperature is not because you added or took away heat. It's not because you put it in the fridge. You mix two things together and you felt a change in temperature. That's it. Chemical changes occur when you mix together and when you mix two different things together to create different chemicals. And what you mix is called a reactant. When you mix things together, these are your reactants. And what you get at the end are your products, right? A factory will take different things and put them together to make a product. So your reactants are what you're using to make your products. The mixture will result in a chemical reaction. So back again, classic example. We have vinegar, baking soda. We have our reactants, right? You take vinegar, baking soda, and what does that make? Well, you create water, carbon dioxide, and a chemical called sodium acetate. This would be a video of different chemical reactions. You can check it out on your own on my notes onto D2L. Signs of a physical change. A physical change occurs when you have a change of state. For example, freezing, turning into a solid when cold. Melting, turning into a liquid when heating. And vaporization or evaporation, turning into a gas when heated. So a physical change is just a change of state. You don't have different chemicals, you don't have a new substance, you don't really create a new smell. It's still the same atoms, it's still the same molecules. It's just that when you melt iron, well, the iron atoms are moving, right? When you react to iron, well, you're creating a different type of chemical. Signs of a chemical change, again, temperature, so know this. We already covered that. And that's it. That's our introduction to mix and flow matter. You need to know what matter is. You need to know what the study of matter is, chemistry. You need to know what matter is made out of, atoms. You need to understand that different atoms can have different properties. And when they come together, they make something completely different. You need to know the three states of matter: solid, liquid, and gas. And you need to know to change from solid, liquid to gas depends on how much energy you have. Adding energy moves from solid to liquid. Adding more energy goes from liquid to gas, while taking away energy goes in the opposite direction. You need to know that solid, liquids, and gas are a result of the molecules and the atoms moving faster or slower. So solids have very slow moving atoms or molecules. Liquids in the middle. And gas, they're moving around. So solids don't have a lot of space in between them. Liquids have a little bit of space. And gases have the most amount of space. Know these three things. It's the same thing I just said. Fourth state of matter, I'm probably not going to test you on it, just more for interest's sake. You need to understand what a physical change is when you move from solid, liquid to gas, right? If it doesn't talk about that, then you probably have a chemical change. You need to know what melting is. Everyone knows what melting is. Ice to liquid. Freezing, liquid to ice. Evaporation or vaporization, liquid to gas. Condensation, gas to liquid. Deposition, gas to solid. And solid to gas is sublimation. You need to know what a chemical change is. And a chemical change is just a change in the molecules. You have molecules here, you have different molecules here. When you melt iron, you have iron molecules here, solid iron, and liquid iron. They're the same. Here you have methane and oxygen, you have CO2 and H2O. Chemical changes, you may smell something, you may feel a change in temperature, you may see a color, know that. You need to know what reactants are, you need to know what products are, and you need to know what a chemical reaction is. Basically, a chemical reaction is when you get new chemicals. And you need to know the signs of a physical change, which is pretty easy, to be honest. So hopefully that helped, and see you next lesson.